Have you ever noticed how your smart speaker seems to know exactly what you're asking it? Or how you can talk to your phone and it instantly turns your voice into a text message or a search result? These digital interactions are powered by artificial intelligence, or AI. When you ask a question, your voice travels out of your room as a stream of data, zipping across the internet to computer networks that figure out the answer and send it back in milliseconds. This technology is a standard part of life now, but early AI couldn't match the logic of a human toddler, and it took up much more space than a pocket. This is what computers looked like in the 1950s. We're looking at giant walls of dials, switches, and panels that took up entire rooms just to do simple math. These machines didn't have any common sense. A human operator had to manually wire and program every single step for them to solve the easiest problems. To get from those massive calculators to the apps we use today, engineers had to solve specific technical hurdles, with each breakthrough opening the door for the next. The central challenge shifted from building better hardware to finding a way for a computer to improve through its own experience. The journey started when a mathematician named Alan Turing asked if machines could think. To test this idea, scientists wrote the first AI program to play a game of checkers. They used a system called rule-based AI. This meant programmers had to manually type out every single possible move in the game as an if-then command. If the opponent moves left, then jump right. This logic works for a board game, but you cannot write a manual command for every unpredictable situation in the real world. There is simply too much information for humans to code by hand. Because of this limitation, the technology hit a wall. Progress slowed, funding stopped, and the industry entered a quiet period known as the AI winter. To move past that winter, researchers realized they had to stop writing rigid rules and invent a way for machines to teach themselves. The solution was machine learning. Instead of giving the computer a rulebook, researchers began giving it thousands of examples to study. In this system, if you want a computer to recognize a dog, you feed it thousands of photos of dogs and cats mixed together. The computer looks at the data and starts to identify patterns. It learns that floppy ears or whiskers are mathematical shapes that repeat, eventually telling the animals apart without a human ever defining what a dog is. This computer is Deep Blue. In 1997, it used this pattern recognition method to analyze millions of previous chess moves and defeated the human world champion. That victory proved that feeding a machine massive amounts of data is a more effective strategy than trying to write all the rules yourself. Computers had mastered games, but they still struggled with human speech. Language is complicated because words can mean different things depending on how they are used. To solve this, scientists looked at the human brain for inspiration and created digital networks modeled after biological neurons. In this network, digital nodes take a tiny fragment of information, process it, and pass it along to the next node to help form a conclusion. When thousands of these layers are stacked together, it is called deep learning. This allows the computer to process vast, interconnected streams of information at the same time. Here is IBM's Watson on Jeopardy in 2011. Using deep learning, it analyzed tricky wordplay, understood human language, and won the game. This combination of deep learning and the massive scale of the internet is what makes the conversational AI in your pocket possible. With these advancements, it's easy to assume we've built the independent robot friends seen in movies. But in reality, we currently rely on narrow AI. This self-driving car is excellent at analyzing the road and calculating routes, but it cannot play checkers or understand a joke. Even robotic pets, like these IBO models, operate within specific parameters. They use sensors and programs designed for specific tasks. The general AI seen in science fiction, a machine that can learn any human task, does not exist in the real world yet. AI is a specialized tool. It doesn't have feelings, and it doesn't experience the world. It strictly follows the patterns we have taught it. Because AI learns from human data, it comes with a risk. If we train an AI using unfair or incorrect examples, the machine will repeat those mistakes. It can also be used to create deepfakes, videos or audio that look real but are completely generated by computer. This makes it important to think critically about what we see online. The future of this technology depends on the people building it and training the next generation of programs. While machines can process data at light speed, they have no sense of empathy or intent. It can predict the next word in a sentence, but it doesn't understand why a friend needs a kind word, or how to imagine a future that doesn't exist yet. That is why human traits like kindness and creativity are the essential guides for these machines. AI is a tool that improves the more we teach it. Now it's up to you to decide where that progress leads.